Hi there. Good afternoon, everyone. Let me confirm if everyone can hear my voice clearly. So I'll start my lecture this afternoon. My name is Tien-Yin Chou. I'm from the GIS Research Center in Huang University. On behalf of Taiwan Space Union, let me express my welcome to all of you who participate in this online GIS course, which is programmed by the Taiwan Space Union. It's a free registration and free certificate online course continuously for 6 lectures. And the final one in December 27, we'll have some kind of final project and some kind of presentation from all the participants who would like to get a certificate. And every Wednesday afternoon for last about 2 hours, Taiwan time is from 2 p.m. to 4 p.m., which should be matched to most of your country's time zone, probably a different time zone. But we're offer this kind of courses, talk about GIS and remote sensing, and also about the application in different prospects. For example, in like today, I'm going to talk about the smart transportation and logistic issue and using the GIS and remote sensing. And also previous week, I talked about the smart city. And for the next 3 weeks, there will be data cube, there will be disaster management, and also there will be some kind of drone application by different lectures. So I hope you're enjoying the course. So let me start this afternoon's course. My name is Tien-Yin Chou. I'm a professor in GIS Research Center in Huang University in Taiwan. I got my bachelor and master degree from National Zhongxin University in Taiwan, and also got my PhD in Michigan State University in US. So currently, I'm director and also a professor in the GIS Research Center in the Huang University. And also I serve as a president of the Taiwan Agriculture Information Technology Association and as a chair for Open Geospatial Consortium, Asia Forum, and also serve as a Secretary General of the Asia Pacific Federation for Information Technology in Agriculture, which is called EPIFITA. So EPIFITA hosts annually international conference regarding the smart agriculture and some of the application. So next November, the EPIFITA annual meeting will be hosted in Tsukuba, Japan, near Tokyo. So you're all welcome to join that event. And on behalf of the Taiwan Space Union, Taiwan Space Union is a nonprofit organization trying to become some kind of bridge between the governmental and private sector in Taiwan, and also promote some of the education to different parts in the world. So this is one of the reasons why the TSU tried to organize this GIS online course. This is already the 4th course being arranged by the Taiwan Space Union. So previously, for the past 2 years, there has been different object courses has been arranged online. You can check all those courses still in the Taiwan Space Union website. You're welcome to check it. And all the courses will be recorded and also stored in some database inside the Taiwan Space Union website. So this afternoon, I'm going to talk about the smart transportation and logistics with GIS and remote sensing. For the previous 2 weeks, I talked about what does GIS mean, how we can use the vector file and also the raster file or some kind of grid or pixel to represent the entire world, and how we can analyze, use those kind of information. And also the previous week, just last week, I mentioned about some of the smart city issue, like how we can call a city a smart one or an intelligent one, because it has lots of like wireless communication and also lots of different kind of integration systems. So this afternoon, I'm going to talk about the transportation and logistics. The transportation and logistics is one of the very, very hot issues in the world. especially during the COVID-19 period, lasts for about 2 to 3 years. The logistic has become one of the hottest issue in most part in the world. Everyone wants to order something on the web and directly deliver to his or her house or any kind of convenience store or some kind of apartment, or to get something directly transported to some other world. So when we mention about the logistic, we're talking about where you are, where you want this order goes to, and where are those goods, how that can be delivered to anyone who need it, or anyone who buy it, or anyone who order it. So as you can see in this graph, the location is one of the key issue of the logistics, because we know exactly who or where to send these goods to, and we know where or who own or who is manufacturing this kind of goods and deliver to where. So there are warehouse, and there are grocery, and there's a home to home, or there are so many different kind of transportation needed, either through airplanes, through trains, through cargo ship, through the motorcycle or a truck. And also you need to record each item. For example, like in mainland China, the November 11 is a single day. So that is the day everyone is ordering lots of goods. There are billions of goods being ordered from the web. And also in the US, just the last week, it was Thanksgiving weekend. And there are also billions of goods being sent through Amazon or through any kind of website, ordering website. So there are so many goods need to be transported to different places every day, or even every hour, or even every second. And how we can make a good logistic way, and also how we can make a very good transportation issue to become safer and efficiently, and also to meet the current, everyone talk about the ESG, SDGs, those kind of requirements as a sustainable things. So that's the issue I'm going to talk about in this afternoon. So let's check about the logistic or the transportation. When we say the logistic or the transportation, it's really complicated. Just like I mentioned about the GIS and remote sensing and all the data, the attribute data, the spatial data, the reason for that is we can exactly record the entire environment. The logistic and transportation is something if anyone need to send someone or something to somewhere. So it's always location based, because their location who grow the plants, or who make the raw material, or who is sampling the entire product, or who is making the final product. And we need the logistic, we need the transportation to transport to different places. Like now we say in the world, there's no border, because you might have your clothes being manufactured in different country. You might have your car being manufactured in different country, or most of those parts has been assembled in different country, in different part of the world. So it's a kind of world business. Depend on the supply, depend on the demand. So it's a supply chain, it's a demand chain. So there are lots of issues are going on every day in the world about the transportation, about the logistics. So that's why if we can do something, make it smarter enough, or to make it more efficient, or to make it save some kind of gasoline, or to become more environmental sensitivity, which we can become a kind of sustainable environment. So there are lots of different kinds of modules of the logistics management system, like how you can order the things, the goods, either the sofa in your living room, or the food, or any kind of pizza. So the order management needs a module. The inventory where to store those goods, or to store those material, or to store those whatever. So there's an inventory management module. And also there's a freight management module. Depend on if you're transport, what kind of cargo, what kind of ship or airplane, and there are warehouse. On those warehouse, you can store those goods or store those material or store those products. And we need transportation. You need either someone to drive or someone to manipulate the kind of vehicle or autonomous vehicle to go somewhere, or even a UAV. And manufacturing, where comes the material? Where comes the raw material? Where comes the assembly line? Where comes the final product? Who is making the package? And analytics and reporting module. So all this module is very necessary in the logistic management system. So this is also one of the important issue I would like to talk about in this afternoon. The transportation, logistic is regarding to everything. The loader, the warehouse, the shipping, the control, the tanker, the truck, the delivery, the airplane, the packaging, everything, or even a robot. So everything is connected to each other. And that's, we say, the logistics. And nowadays, how we can know, because I mentioned about it's a world issue. So in the world, how you can know exactly the location? There are many, many different ways. The most convenient way is use the satellite. Like before, the US launched the GPS satellite. So we say the GPS system. And after that, there are so many, Russia, the mainland China, the India, the Japan, Israel, they all launched different kind of navigation satellite. So in the world, there are several global navigation satellite systems around some orbit of the Earth. And it's always like just go around the Earth. So each satellite is in the altitude nearly 20,000 meters high, which is a perfect place for the coverage. And also each satellite might rotate the Earth probably nearly twice a day. So all the satellite is trying to keep a kind of gravity and also with the outward movement, the forces is a kind of balance, and it needs another forward moving to keep it without the gravity force. So all the kind of global navigation satellite system can provide a very good position, speed, timing, service, most of the area. Because there's so many different kind of GNSS. Before we say GPS, because it's owned and operated by United States, and it's most common one. Ever since the 1978, it becomes one of the most popular. And also the President Clinton released the SA effect. So it changed like from the accuracy of nearly 7 meter, 80 meter or to 100 meters accuracy now is to about 3 to 5 meters accuracy of the GPS. You can just use your cell phone, use the GPS. And also the Russian has GLONASS. And mainland China just recently has already launched nearly 29 the Beidou satellite. And also the European Union, the Galileo. The Galileo has already 28 satellites already been launched to different orbits above the Earth. And also the Japan, the India, they all have different satellites, but it's only regional now. But they aim to serve the globally one. So nowadays, there are probably 4 major navigation satellite, which we say the GNSS, the Global Navigation Satellite Systems. There are 4 major one: the GPS one, the GLONASS one, the Galileo one, the Beidou one. Most of those receivers can receive different systems. And nowadays, most of the cell phone can receive probably 4 of that. So which means there are over 100 navigation satellite is capable to serve any part in the world. So we can receive nearly 100 satellite and sending out the signal. And the reason why the global positioning satellite will be able to get to know the location. Let's look at the satellite. When the satellite is go around the Earth, and also the Earth is also rotate by itself. We say the navigation satellite. What I mean is by about near the altitude of 20,000 to 30,000 meters altitude. So it keep this way as different kind of forces is balanced. So when the Earth is moving, it's also moving along the Earth and in different direction. And also, so we say every satellite might around the Earth probably twice a day, depending on the altitude of this kind of systems. If there's one satellite, only one satellite, and we can count about the distance between the satellite to the Earth, which I say is about nearly 20 to 30,000 meters. And the distance is equal to the velocity multiply the time. And the velocity is the speed of light, which we say is 2.8 times 10 of the power of 8. Or we say 3 times 10 power of 8 meters. So for any satellite to send a signal to the Earth, because of the distance, so if it's the speed of the light, it needs only 0.001. It's 1 of 1,000 seconds to the Earth. So we know exactly if I have a very good clock, and the clock can go as precise as 0.0000001, then I'll be able to calculate the exact time of the distance. So distance between the satellite and the receiver, I can calculate it using the speed of light. And if I have one satellite, so put the satellite as the center of the circle with the distance as the radius, and the circle can be drawn. So the entire circle you'll be able to draw. So I must be over here on the Earth. So the receiver can be located at any point of the circle. So that's this circle. So I know exactly, okay, I must be here because I received this satellite and I know who this satellite is. I know what is the satellite location on the orbit, and I know the distance. So I know exactly I might be somewhere over here, but this is only using one navigation satellite. So if there are 2, I know exactly who this satellite is, and I receive 2 distance. So I can calculate I must be on the center of this one. So I know my possible location is the red one now. So there are 2 satellites. The third one means, okay, I must be here. So that's exactly where I am. So the receiver, the GNSS receiver, when it can receive more than 3 satellites, it can give me exact point in the world, in the globally. And I can use the fourth one as a position arrow calibration for the fourth one. So I know exactly where I am now, very precise. Nowadays, the technology of this, we can use just the global navigation satellite to nearly like 5 to 10 meters of the accuracy for every civil use. Of course, the military use or defense use, it might be more precise, but it needs some other calculation and some other information directly from the satellite. But for most of the common use by the civil one, we can use different kind of global navigation satellite systems and count exactly as 5 to 10 meters of accuracy. And that's sufficient enough because we know almost where you are. So that's why when you have a cell phone and your cell phone is keep receiving all the different kind of navigation satellite information, and all those satellite information is always sending some kind of information directly to the Earth. So when your receiver can receive 3 to 4 different satellite and sending the signal to your receiver, then your receiver will be able to calculate the exact location where you are. So that's how we can use we say GPS, but in fact it's a GNSS because it's not necessarily only the US satellite. So might be the GLONASS, might be the Galileo, might be the Beidou. So most of your cell phone, inside your cell phone, the receiver can receive those 4 major satellite systems now and can get a very good, precise location just by 5 to 10 meters accuracy. So that's why when you have your cell phone and if you go around, we know exactly where you are because your cell phone is still receiving the satellite information directly, and depend on if you are sending that kind of signal through your communication system, through your SIM card. And also most of the telecommunication company, they have some other system. They can use your SIM card, or they can use some kind of the Wi-Fi technology or some other communication technology to calculate even more precise location, which means we can use the Wi-Fi, we can use some other technology to get a very precise, much better than the satellite can provide. So some of the indoor navigation, they can use the Wi-Fi, they can use some other communication technology, like the ultra wideband or some other like the beacon. And there are so many different kind of wireless technology nowadays has been developed. There are different algorithms to calculate the exact location through not only the satellite, but through the telecommunication base station, through Wi-Fi, through different kind of wireless communication. Like I say, like the beacon, like the other way, the ROLA, the NB-IoT, or any other way, we'll be able to calculate as long as you're making some kind of communication or you're receiving some of the signal. Then we'll be able to calculate exactly where you are. So that's the way we can get a location. As I mentioned about, when we say about logistics, when we say about the transportation, the location is one of the most important things because you need to know where to plant those raw material, where to mine those raw material, and where to make the material, where to resampling the product, and where to manufacturing those kind of things, and where to send it to, and where is the warehouse, where to store it. Do I need to get a cold chain? Do I need to get it into freezer or refrigerator or some kind of special content? So there are so many issues regarding the transportation and logistic. But as long as we know exactly where we are, there are always a lot of different kind of application in daily life. So there is uncountable GNSS applications. Like now we use the GNSS when you try to find your best route, when you try to get some kind of navigation from here to a specific restaurant or even go back home. So road navigation, travel recording, and search function. Like now in Taiwan, there are people eager for hiking. But lots of people during some of the bad weather or the bad condition or some of the accident happened, and those hiker, they might be lost in the forest. So the only way to find them is through their cell phone or through some kind of navigation system, enable others to know where he or she is now. So there are lots of this kind of application every day using the good location base through the GNSS service or some other way of service. So if we know exactly all those systems, if you think about the manufacturing, think about the product, think about the industrial, everyone has certain needs and they need to buy something, they need to order something or they need to make something. Then you need the good transportation, either through airplane, through ships, through trucks, or whatever. So there's a fleet management systems. Fleet management system was one of the major issue of the transportation, because the transportation tried to get a very good management for the entire group. So there are lots of industrial in the world try to have very good fleet management systems. And it's under the logistic, because nowadays we have transformed the fleet management system into logistic system. Because not only the fleet management, but also the best routes, and also how you can manage the good driver, how you can manage a good or correct or more efficient way to use the truck or to use the good transportation vehicle to save some film or to save your time and to avoid some of the idling time. So that's a major issue of the transportation, of the logistics, and of the fleet management system. So it's all connected. All this kind of system use a lot of the global navigation systems, satellite systems, or the Wi-Fi, or some other way. So there are lots of this kind of thing. There are always some of the center and everything. They need a map, because you know your location, but you have no way to showing where you are. So you need a map. And this kind of map, as my previous two talks about a two-dimensional map or even three-dimensional map. Like nowadays in Taiwan, the government try to provide a service of three-dimensional maps. The building, the road, the underground pipelines, all those things in the three-dimensional one. So the cartography and everything we say today is all concerned about the logistic, transportation, fleet management. So if we say the smart transportation, or we say the smart logistics, we're talking about lots of things. We talk about the driving attention assistance to keep the driver. As long as we still have a driver in a car, we still need something to keep the driver's attention, unless we have autonomous. But autonomous vehicle, it's a huge issue now also. But still, there are some kind of obstacle, and there are also some kind of disadvantage of using the autonomous. So in Taiwan, only the highway you can use the level, probably level 1.5 or level 2 autonomous driving vehicle. in the highway, not for the common city roadway. And also the monitoring platform, because you need to monitor not only the vehicle itself, but also the goods and also the material, lots of things you need to monitor. And there are always some kind of big data analysis service, because like I mentioned about, like for some of the special events, the special holiday in mainland China, the November 11th, the special Thanksgiving weekend in US and European country, there are billions of the logistic demand. So there are billions of the data set. Who order what from where? And where is those goods? Will they be sent on time or not? And how we can pack those goods in the most efficient way. So the big data analysis service is also one of the very, very important one. One of the very, very important one. So let me show to you, like, well, when we say the smart transportation, and we're saying the driving support system. So in the industry of Taiwan, there's so many private companies, and they also work together with the public sector. Try to get the drivers more attention, especially on the highway. So the kind of like fall asleep or very feel sleepy, or some kind of warning, or some kind of monitoring system has already been enforcement in Taiwan in some of the rule or regulation. So in most part, especially in the highway or some of the transportation for some low radiation or some of the dangerous goods like the gasoline or the gas, those kind of transportation is a very high rule to request all the vehicle has to be equipped with certain facility. So when we say the intelligent transportation management, we're talking about the 9 aspects: for the driver, for the vehicle, and for the goods. And also there are lots of things before the transportation event can be happen. There is a before duty or on the duty, during the process or after the duty. So there are 9, we say 9 aspects of the intelligent transportation management nowadays. Let me express this one, use one of the private industrial company in Taiwan. That company already developed a very good intelligent transportation management system in Taiwan and serve as a major one, the customized intelligent transportation management for many logistic company already. So let me introduce some of the application in Taiwan from the private and also from the public sector regarding this kind of 9 aspect. So let's talk about for the driver before the duty. Some of the logistic company in Taiwan ask the driver to make sure you are the driver and you drive certain vehicle and go somewhere. So make sure the driver's blood pressure is okay. And also the other thing is the alcohol testing, because sometimes if the driver got drunk last night, he or she might still have the kind of alcohol concentration is over the limit. Like in Taiwan, if you have a alcohol testing higher than 0.15, you cannot drive because you're still being influenced because of the alcohol. So make sure all the drivers they are under or they are 0 for the alcohol testing, and also the blood pressure, because in Taiwan there are also some report of the drivers suddenly just fall asleep during the road because of the blood pressure was changing. And also the driver has to carry his or her cell phone to go around the truck, make sure every tire is in full condition. So inspection and everything goes to the cloud. Then the gate will open and the driver can drive his vehicle and to send the goods. So there are already a lot of autonomous logistic company. If they have some kind of like vehicle cargo places, and they can ask the driver to do this kind of things. And for the second one about the vehicle inspection, and also in Taiwan, the truck might carry different trailer. So the trailer automatic recognition and the gate security control. For example, the tractor in front with the trailer sometimes different. So not every tractor is always carry the same trailer. So it might change. So which tractor with which trailer? This is also one of very important one. So it can calculate because every tractor is owned or driven by a different driver. So who is driving this one? And also calculate the mileage of the wheel because the driver's behavior, the tractor and the trailer, the wheel maintenance is different. Some of the drivers can have very, very good driving behavior. They can maintain like every 20,000 mileage. Then after 20,000 mileage, then you need to change the tire. But some of driver, if he used to just suddenly stop, suddenly just push the gas, then the wheel or the tire maintenance sometimes like just 15,000 or even lower, then it need to be replaced. So it's a different kind of driver behavior. And also for the goods, if you can automatically dispatching the goods to different vehicle, to different driver, and how you can make the good task. Every driver should have a fair tasking issue every day, and how you can put a notice into the driver's cell phone or some kind of facility. So in Taiwan, every system nowadays writing the kind of source code, now we use the RWD. RWD means the system will be exactly the same using the website or cell phone or pad. It depends on the size of your monitor. So it's RWD. And also the APP. In Taiwan, the most popular social media is called Line, or we say Line ads, or the online payment, because some of the payment, even by the customer, some of the goods is when you receive that, then you need to pay, or it's already been paid. So online payment and good status inquiry. So everyone wants to know where is my order and where is it? If you order something from the Uber Eats, from the Foodpanda, we always want to know where is the food now. And also interface the original order system, the API. So because every company, they would like to get a very good big data. They would like to know the behavior of the customer, who is prefer ordering what from where, because that person might need different kind of advertisements. So who knows all those information? Who got all those kind of data sets? Who will be the winner? Because they know exactly to send the necessary advertisement to the correct person, because they want to promote the goods or they want to promote the delivery issue. So there are always different kind of things. And also nowadays, the automatic dispatching system, for example, like this one, there's a daily order collection. Every day is different. and every driver, every vehicle, or every goods is required to send in different time zone. And also the parameter adjustment, because for the driver in Taiwan, you cannot have the driver overtime. And also all the company would like to shortest idle time. They want every driver to share the same kind of loading and shortest empty the car and also the car movement, because it can be more efficient. So there are lots of issues you have to consider about. And it's a big table. It's a really big table. And there are lots of data, like where to go and where to get the loading or unloading and from where at what time. And all this kind of time schedule is changing every day, every second, every minute. So you have to have a good system, because most often we have the multiple task matching. We have hundreds of the vehicle. We have thousands, millions of the goods. And we have hundreds of the delivery site. So everything you need to have some kind of task notifications to different driver or to exact different vehicle. So everyone knows where I should go and put what to where and how at what time. So this kind of AI things, it can serve the customer 1, 2, 3, whatever. So every different customer has different kind of goods, and for every kind of different goods, there are several hundred or thousand different items. So your daily order collection. So the same thing, no overtime, no overload, and get the shortest distance and fit with the time window limit. So how we can dispatching all this kind of goods to, especially some of the goods has thousands of items, is pretty complicated. So we need to get customer A has 5 tons, customer B 5 tons, customer C 3 tons, customer D is 10 tons of the vehicle, customer E is 7 tons. So every vehicle has its own limitation of the cargo weight. How you can then make a good dispatching system by different driver, by different vehicle, by different size of the cargo, and by different goods, and by different number of the item for each good. So as I say, it's so complicated. You need a very good algorithm, and you need someone can very carefully examine the entire things, because if you can make a very good, efficient dispatching way, it saves lots of time, energy, even for the driver. So for all the private industrial company in Taiwan, or even for the public sectors one, like for the post office, they all need this kind of AI automatic dispatching system, because it needs to combine with some of the warehouse, some of the transport. For example, the shortest distance for different driver to drive and to get different payment and some kind of reward, and every driver drive different distance. So if you have 5 drivers, you want each driver to share the same kind of distance and almost share some kind of reward. Then you have to be very careful about ask which driver to go where, to pick up what, and send to where for what kind of goods. So expected arrival time is also a very necessary one when you calculating the exact route and dispatching system. So inside dispatching system is a so complicated one. And also during certain period, there are lots of time you need overloading things to be considered. For example, like in Taiwan, before the Chinese New Year, there are always so many goods need to be sent to different parts inside Taiwan. Just I mentioned about the Thanksgiving weekend in the US, there were billions of goods need to be sent. Everyone wants to send gift to someone else or even for himself. So there's an overload. So you need to know which truck at what time can go where for this kind of overloading things. Exchange task with the neighboring routes and route range in the same area for overloading and shortest distance, working hours, and meet a specific delivery time. Because the customer always asks, you have to send to me at certain time limitation. The customer never care about it's already overloading. It's already a big holiday. It concerned with if you say you will send this goods in 12 hours or in 24 hours, I should receive these goods. Then you have to have it. I need to have it in 24 hours, in 12 hours, even in 6 hours. Or if you're ordering something for the food, you want the food to come to your house like in the next half hour. So there are so many specific delivery time and everything. So it makes the algorithm more complicated one. So the AI automatic dispatching system is one of the very, very important ones for logistic transportation management. And also different vehicles, different vehicle transport. For example, like this one. You're looking at in Taiwan. This is one of the systems for one of the major company, like the Toyota company. They have different family of the module of car. And different module of car because it's different size, different weight. And it has to be fit in different slots. Like as you can see on the graph, there are 8 slots, but not every vehicle can fit every slot. Certain vehicle has to go fit with that slot. And there has to be some kind of sequence. How you can put exactly 8 cars in this trailer. And that's depend on a lot of previous knowledge, a lot of things. You have to have very good experience. But now we can ask the AI to make automatic dispatching. As long as we know the rule, we know exactly the limitation, we know exactly what kind of tolerance it is, what kind of limitation, what kind of restraint it is. Then we can write the algorithm and we can ask the computer to do the AI. But before that, it has to be depend on very, very good experienced person to really organize a good dispatching system of this. So this kind of AI automatic dispatching system is also one of the very important, like from the Taipei port and back to Tainan, to the southern Taiwan, or to the North Taiwan, and where to go out, to go south, to go south, go north, and from the seaport to the city. So there are lots of things. And also express delivery, corporate car rental, just like the Uber. You can search for the most suitable vehicle, like vehicle type, nearest distance, cumulative income, service rating, and fleet priority. Then just like Uber, arrange the best route, meet a specific time because you want to arrive certain places in specific time, and pick up before delivery, shortest distance, task notification. So just like if you want to order something, it's always changes dynamics. And also the computer should be able to reroute and should be able to calculate the best route and exactly the time for anyone who needs it, because it's a demand world now. So for our customer who want to get certain kind of deliverable goods to his doorstep, he always want to know when, where, go, and how. So everyone needs to get as fast, as efficient as they can. Okay, so I've been talking about this for about 50 minutes. Let's take a short break. So let's take about 10 minutes break. So exactly after 10 minutes, please come back to this online lecture courses about the GIS. This afternoon, I'm going to talk about the transportation and logistic management use the GIS and remote sensing. So I'll still explain some of the real application issues in Taiwan as the driver, as the vehicle, and as the goods when on duty and after duty. So let's take a short break. Thank you. Okay, good. Thank you. So I will continue my talk about when the drivers are on the duty. There are so many things you need to monitor because like in Taiwan, it requires, especially for the alcohol testing, some of the driver, if he or she has has been some kind of historical alcohol driving issue, then they have to put some kind of alcohol testing things under their vehicle. They have to prove they are zero alcohol, then they can drive the car. And some of the logistic company in Taiwan, they ask all the vehicle to equip with this kind of very easy use disposable alcohol testing things. So there are lots of the system. You have to prove you are less than certain amount of alcohol concentration or even zero. Then you can really drive it. And also there are lots of different kinds of system being equipped inside the vehicle. For example, the vehicle might be equipped with the kind of collision warning because the vehicle, the distance too close or departure from the lane, and rapid acceleration and rapid brake or rapid turns and rollover. So all this kind of thing may be recorded. Well, this is supposed to be a video, but now like this kind of, if the driver is for sleep, it's very easy for the sensor to identify if he closes his eyes for more than 2 seconds. So like this one, we can use the sensor to directly identify if it's too close. Like nowadays, already being certain kind of standard equipment for certain kind of vehicle. But still, if we have a sensor, the sensor will be able to identify if the driver has closed the eyes for more than 2 seconds. So like this one, then the computer itself will send back to the manager about this image. And also like this one, like this driver is also close his eyes during the drive. This is, they both are exactly on the driving status. And like this one, the driver is driving, is looking at his cell phone, and the sensor keep annoying him, saying, you have to be, watch out, you have to be careful because you already is not paying your attention on the roads. So he feels very annoying by the sensors. So he used a cloth to cover the sensor. These are a real video being recorded, and also all this kind of sensor, like this one, sensor automatically send back this information directly to the manager. So for those logistic company in Taiwan, they would like to have this kind of sensor to be equipped in most of their vehicle. Even like this one, the driver was supposed to be at this exact position, but you can see now he's lost, and the car is in the 92 kilometer per hour speed, a very stable speed. So probably the driver is looking for something, but it's pretty dangerous because this is on the highway, this is on, and also this is on the country road, and as you can see, the driver keeps smoking, and also he drive even in the opposite way. So it's quite dangerous, and also the entire sensor just keep sending back all the information. Like if the driver has already been over, like when he's making the turn, he did not brake. So sometimes he just may go to the opposite way. So this is entirely opposite way. So he's supposed to go to the right lane. So all these kind of things, the return more than 10 abnormal images within 3 minutes. So automatically it's sent back this kind of abnormal. And who find out this kind of abnormal? The computer itself. It's not a certain person. Look at all the thousands of video for each car. The computer found out this is abnormal images. So the computer will send back all this kind of thing, and the entire image and everything will store on the storage. So there is warning sound and there vibration prompt and notify everything. Try to warn the driver and try to remind the manager. So manager can come into a speakerphone directory, ask the driver to be awake, to avoid those kind of dangers. So even when the vehicle is on the road, on the duty, so if it's on time or not, like if there has been abnormal things, the complete system itself, it will record abnormal one, like speeding or over the time limit, or is not follow the correct route, or even crossing the road or whatever. So just hit this one and it will show up the 30 seconds of each video being recorded, and it stored that. So the entire information is storing in the hard drive and on the cloud. So we can see exactly what's happening now. And even nowadays, for lots of the vehicle, it's already a basic standard equipment. But for this kind of system, I can exactly put where he is and what's the surrounding of the vehicle directly by this way. And everything is on the cloud. So everything can keep a long time history. Like if there are abnormal images, so I just hit this one, and the computer will get all this kind of abnormal. You can see this driver, he is eating his lunchbox and checking the cell phone. So this is very abnormal one. So all these kind of things, we know exactly which driver is doing what because of abnormal one, So everything will be recorded, and also at the same time notify the manager, and also make some kind of sound like this one. He rushed out for the red lights. And we can even do this kind of things like during that time or post, because he has to stop, but he didn't. He just keep running for that. And also if they're over time or there's a deviate of the route, or there any kind of abnormal one, the entire thing will be recorded for several seconds in different video. And also I can check individual tracking and monitoring just on one system. I can very easily to change which one I'm looking at and whatever. So I can just check this one, and every vehicle has 4 to 8 video camera inside and outside the vehicle. Then I can check all the video directly. So in Taiwan, there are lots of this kind of logistic company has already been put this kind of device into their daily job. And all the drivers in the very beginning, several years ago, all the drivers were pretty opposed to this kind of action. They think, I don't want to be monitored. I don't want to be like detected every second. But after several very severe events during the road, those drivers find out this kind of system might be able to protect their safety even, because everything is recorded and there are always the kind of proof. There's their video, there are lots of things. And also for different driver, if they're a very good driver, they would like to have this system for the company because they would like to show they are the good one. So we can check all the driver behavior very easily, if this driver or that driver who is making a good driving behavior. So all this kind of thing will be able to make it, or speeding one, like, or the map itself for those kind of logistic company. The basic requirement is some of logistic company, they have their certain rule. It's not follow the speedy limitation, but because of the size of the truck or because of the goods they're sending, probably some is in the freezer or some is in dangerous one or low radiation one, then they have different limitation on the road. So they need to make their own restriction about each road speed, about speed limitation. So they need to have a system. They can put their own limit or speed limit in different roads. So this is one of very basic function for logistic monitoring or logistic management in Taiwan. There are lots of different logistic companies. They have different restrictions. They have their own rule. Or we can make certain kind of geofence, which means you can make these certain places as a place all the driver has to be in, or all the driver cannot comes in. So you know exactly if the driver has already been in this area and go here, go there, and inside that area. So automatically check it. And also you can have a board to show a normal management board. Each driver, every day, I can use this kind of board to showing if he's been speeding, how many times, if he's been fall asleep, how many times, if he's been turning right without putting the signal first, how many times, and everything. So you have number, you have figure, you have table. So you can get exactly how is the driver's behavior. And all these kind of things, we can count it as time or the times of the event. So depend on how you can count each one. So you can get the different drivers or different vehicle or different route. You can use certain kind of grading system, and you can make this kind of report. You know exactly who was driving which vehicle in which road and over speed for how long, or doing something for how long. So when we say the AI dispatching platform, we search for the best driver behavior. We search for the best route. So that's meant by the AI. So artificial intelligence can be used in many aspects. As the previous lecture, I talking about the GIS. We use a lot of the spatially related issue and use the AI to find out the best way, the most efficient way. And also the same thing. We can find the best driver behavior. We can search for the best route. The best route might not be the shortest one, but it's the best one. Because some company focus on the economics, some company focus on the efficient, some company even focus on environment. So depend on your weighting factor. You can find your best route. And also we can easily to have some kind of like displaying board to display if this manufacturing factors, everything has been sent in certain time limit, like now is 10:30. So I can draw a line and I know exactly if all the truck is already on time or not, or it's delayed or whatever. So we know the orange line, the green line, the red line means different status. If it's been delayed, if it's been on time, or it's been above time. So all this kind of information is very useful for every logistic company, or even for manufacturing, for manufacturing factory. We can get to know the delivery progress board. we can know exactly, use different color, the blue, the red, the green, the gray, to represent different progress. Like the gray one means it's not in the store, the green is in the store, or the black is on time, the blue is advanced, and the red is delayed. So we know exactly, like this convenience store, we will have some of the vegetable will be delayed. And we know the other convenience store, some of the things has been advanced. It's already there. It's before the time limitation. So we know exactly who sent what in what time, and if it's on time, it's advanced, it's delayed. And for all the manager, they can use a very simple app, and they can check everything directly on their cell phone. So on their cell phone, they can check everything, just like the one I showed to you. If the driver was on time, if the driver is in a good behavior, and if everything is correct, and even for the monitoring. So even for the emergency vehicle in Taiwan has put a lot of this kind of monitoring issues, because even for the emergency or some other, lots of different kind of application has been used in different way. They need to know the driving attention. They need to have different kind of driving record, the GPS. When we say GPS, sometimes it's a GNSS, but we just still use a GPS receiver. But in fact, it's a GNSS receiver. And sometimes we have a temperature tracking and tire pressure detecting, driving recorded. And in Taiwan, lots of this kind of convenience store, when they send a kind of logistic issue, there might be freezer, there might be refrigerator, it's different temperature. So they need to know exactly who opened the door and open for how long, because while you open the door to get some of the goods out or put something in, you lose some temperature. And fridge door and everything, we can put a lot of sensors, and we can have a touch panel in front of the driver. So the driver exactly know which goods to go where and at what time. Everything, if the compressor is correctly for the air conditioning, to make sure all the goods did not lose its temperature on the way. And also we say the tracker. And in Taiwan, some of the vehicle has been equipped, especially for the truck or the bus, the big tour bus. They all have blind spot camera, because when you make a certain left-hand drive or left-hand turn or right-hand turn, some of the places it's a blind spot. Then we should have some kind of blind spot camera, and also on the back for the reverse camera. So there are so many things you'll be able to detect using those kind of sensors in the camera. So we can do the real-time monitoring for all the things, And we can make some kind of abnormal management of all these kind of things. So we can have this kind of statistics, daily report. So we can have the kind of daily report of those kind of statistics, because we know exactly real-time monitoring and abnormal management. Then we can make a lot of things just through this kind of sensors. So using the sensor, we know exactly the location. Using the sensor, we know exactly what the driver is doing. We know exactly how was it and how is it and how will be. And we know exactly if it's on time or not. We know exactly if it's delayed or not. And we can even remind the driver. We can even to make a caution to this kind of transport mission. And in Taiwan, most of this kind of toolbar is required to put some kind of blind spot early warning assistance system. Because in Taiwan, it happened a lot of times. There are always some kind of motorcycle around the big tour bus. And when it's making the right turn or left turn, it cannot see there are people, or there are a motorcycle or bicycle, an elder person. And without any kind of notification, then some of the accident happened. It happened in Taiwan. So most of this kind of tool truck or tool bus has been required to put the kind of blind spot early warning assistant. And for the driver, make sure you are the driver. So the driver can use the same thing as a cell phone for the selfie. So use a cell phone. The cell phone will be able to identify, yes, you are the driver. So you are the one who's driving the car. And also for all the goods. On the duty, we can have the face recognition, and then the driver can log in. And task notification, and the driver will be able to know where to send and what kind of task, and check the goods using a barcode scanner. Just photo it, use a barcode or a QR code, and task search and report, and navigate you to where you should go. And after the mission, and sign it directly, ask the customer to sign it, or you can sign it. So everything can be done just in a cell phone. So it's a real time and track and management. And for the driver itself, the driver can get every information directly through his or her cell phone. From where, go where, and he can just hit the screen and get to know what's the content and which mission it is, and what kind of car it is, and how should I pick the correct vehicle? Where should I get my gasoline, and how much can I get this time? And also, when it's ending, I need to record about the mileage on the vehicle. Then that's it. So for all the driver, they know exactly where to go and where to get something, and how to go there, and how they can get paid. Like every driver is paid by different cargo size, different time zone, and different hour, and different task, different mission. So every driver can get exactly, he knows what he can get, what kind of payment he will get after today. So which is very, very easy or simple, saying, okay, because today you send this one, that one, and this month, and last month, how much is it? So like now, the Uber, the Foodpanda, all this kind of delivery person, they know exactly how much they can get paid for this mission, and for today, for last month, for this month. So the driver would be able to know everything, because either the cell phone or the web or the computer, everything is exactly the same. So make sure this is his mission, then he just needs to sign. Then that's it. So the manager will be able to get to know every driver's condition directly. So the manager can also just directly check from his cell phone about each vehicle's location and who's driving this one, and how about the driver's behavior, everything. So the manager's app get to know also everything, even the goods. And the drivers, they're also different kind of driver for the car carrier trucks, and for the home appearance delivery, and they can sign, and chemical delivery, every different kind of delivery company, different kind of industrial logistic company is different required for their driver app, but it's all based on the same kind of everything. But just the displaying system is different. Only displaying system is different, but all the basic rule and all the algorithms are almost the same. For the home delivery, you can see from the scooter express delivery. So someone is driving a scooter. For the freight transport, a big cargo, a truck. So even the size of vehicle the content of the goods are different, but we can always have the same kind of APP. And for driver after the duty, the driver behavior and the salary and the labor inspection, like if the driver, just as I mentioned about, if the driver has the alcohol testing and blood pressure, so this kind of report can have a very good report about the heartbeat, the blood pressure, and alcohol testing every day, and the speeding situation. And we can have all these kind of things on the graph. So the manager will get to know the health condition of the driver and also the driver behavior, not only the behavior, but the health condition. Like in Taiwan, some of the private logistic or transportation company, they hire the driver and they would like the driver to be sustained. So they would like to know if the driver is always on a good health. So the heartbeat, the blood pressure, everything. And we can make some kind of graph. We make some kind of this kind of table to showing if this driver is in a good condition. And also the driver, if he's driving the vehicle on time, and also the working hour, if he has been taking break more than 50 minutes. In Taiwan, there's a certain kind of rule by the government saying if it's over certain period, you have to have at least 15 minutes break. But who knows all the driver if they get 15 minutes break? But now we know exactly, because we can count directly using the record, using the statistic number. So in Taiwan, most of those kind of very good logistic company, they want to make sure all the drivers follow exactly the rule being requested by the government. Do not overwork and get a good break between different time zones. So it's all requested or restricted in Taiwan. So now we can use this kind of number. Like before, all the driver has to fill out the form, just like the left-hand side, just like this one, has to handwrite this kind of form and sign his name. And it's very complicated. Before, no one understand what it is, and no one understand what means by this. Only very experienced drivers. And also for the manager, he has to be very smart to recognize all the work. But now, all the driver, when they're back to their warehouse or to where the vehicle is, to the garage, this kind of report automatically created. They just need to check it and sign it. Make sure everything is true, because it's making directly through all the sensors directly, not like before. Before you have to record it, you have to sign, you have to make everything, and you cannot make the statistics. It's so hard. But now everything is on the computer. Everything is a digital format, and it's automatically created. So it's automatically generated daily operating report. So this saves a lot of time and energy and the debating. And also for the vehicle, about the mileage, about the consuming of the gasoline, the maintenance, lots of things. Because it's the same thing. Because we know exactly for the vehicle tracking. So we know the driving record per seconds. And also we know the consumption trade, like before and after, about the film, about this driver, about this vehicle. If it has been changed for the percentage of the fuel it consumed. So if there any kind of abnormal, or it's follow the same kind of pattern, or who is making good the fuel saving, like the fuel consumption trade or average fuel consumption analysis. Everything is on digital format, and everything now is visible now. So for the manager, they can make a very good driver behavior grading system. And also for the maintenance, because you know exactly which driver drive which vehicle, drive which trailer, drive which tractor. And you know about the maintenance of the wheel, the tire, the maintenance about the brake, the maintenance about everything. So you can count who has been driving this truck for how long. And if this is a very normal one or abnormal one. So there's so many issues you'll be able to get to know by all these kind of sensors. Or even for those kind of goods, for the delivery progress, all these kind of things, we can have a very simple displaying board, use like just like the Power BI. We can have we say Kanban. It's like a Kanban. It's a Kanban board. It's a displaying board. The displaying board about everything, the cargo tracking, the report, the customer, the account, everything. Depend on where you like to look at and what you like to look at. You like to look at about each driver, or about the average of driver, or about the goods, or about the driving distance, or about the vehicle, or about if the entire warehouse has been on time to deliver certain goods. It all depends what kind of issue you focus on, and the system will be able to automatically create this kind of system. So the driving behavior analysis will be much easier. As long as you have a number for each driver, you know how many times the driver overspeed, how many times the driver stay in certain places he's supposed not to stay there, or has been tired, close his eyes for more than seconds for how many times, or run for the red lights, or illegally turn, or even smoke on the car. So there's so many abnormal records. You'll be able to get a digital format, and you can make a very good driving behavior analysis. You know which driver is much better, which driver is pretty worse one. You have to be very careful. So nowadays in Taiwan, the normal transportation, the normally logistic, we need to focus on if there's a dangerous goods or there's a low radiation one. But now there's also a cold chain supply, and how you can transport those goods has to be put into the freezer or the refrigerator. It's different temperature. Even during the COVID-19 period, some of the doughs has to put a very, very low temperature one, a very low one. But how you can make sure during the transport process, all the doughs are under that kind of temperature limitation, because it cannot be over. Once it's over for certain time period, the entire doughs will be a waste. You cannot use that. So for the cold chain management in Taiwan is one of the major issues, because you need to have special temperature and you need to have special sensors. So this kind of sensor this time for the freezer, for the temperature is more important. Not like the normal one. The normal one, you just need to know something. But for like this one, in Taiwan, some of the grocery store, they use the wired cold chain management. So everything's wired. All the sensors are wired. But for some of the freezer one, you cannot have the wired. So you have to have a wireless one. So when you have to have some kind of wireless, in Taiwan, we test different kind of communication for the wireless one. And we found out the LoRa system works pretty good in very, very low temperature and still can transmit those kind of wireless information back. So LoRa wireless thermometer in Taiwan is one of a very good selling product now, because lots of the cold chain management, they found out use the wireless one, only LoRa wireless the LoRa wireless thermometer is a better one. So use the LoRa one, and with the GPS or GNSS track. So it's a wireless communicate. So we still know if the cargo itself is under certain kind of temperature limitation. And also, there are lots of gateway. Like in Taiwan, we put those kind of LoRa wireless one in the ocean cargo. And during the harbor way, of course, we can use the 4G or 5G communication to transmit it or the temperature in the real time. But in the ocean itself, there is no cell phone station, there's no 4G, there's no 5G. So the only thing we can do is a Wi-Fi intranet on those ship. So on the ship, we know exactly the temperature condition. So the pilots still know the temperature condition of each cargo. So this is the way, but only when they arrive the harbor or departure the harbor, before departure the harbor, they can use the 4G or 5G to transmit it all the information in real time. So the temperature management platform for the real-time monitoring is a very complicated one, because certain goods cannot tolerate to leave out this kind of temperature for certain seconds or minutes or hours. So we have to make sure, sometimes fruits, but if it's COVID-19 dose, or is something very, very important, then we have to make sure it's a traceable temperature. And we know exactly if there is abnormal records. So we need those kind of sensors directly put on different parts of the refrigerator or the freezer. So the traceable temperature like this one. We know the delivery time, the return time, and we know if there's an upper limit or lower limit, and we need to trace it back. If this is still under that tolerance for lower temperature because too cold, or for upper one because too hot. So the system itself will be able to identify if they're lower one, if they're upper one, and make a good statistics. And also, everything is a traceable one. So in Taiwan, not only for those logistic or transportation management company, they require all the vehicle and the driver need to put all those kind of sensors, use a kind of navigation satellite systems to get to know exactly location and the time. And they all have very complicated platform or system to monitor and to make a very good dispatching about the vehicle, about the driver, about the goods. And also in Taiwan, even for some of the city, the cleaning truck is also have real-time GPS things on the truck, because in Taiwan, if you want to have some kind of waste garbage dump, you can only carry your garbage downstairs to the roadside, wait for the garbage truck to come to your neighbor or come to your household, like certain day, like every Tuesday and Thursday afternoon at 5 o'clock. But sometimes the truck will be delayed. Sometimes the truck will be advanced. So you have to wait. So in Taiwan, lots of cities, they also have this kind of things being developed So all the residents live in the city, they can get to know when and where the garbage truck will arrive. Then they can carry their house garbage to wait for the garbage truck. So in Taiwan, lots of this kind of garbage truck tracking system has been developed in most of the cities in Taiwan. In Taiwan, even there's a major traditional, it's an event. It's a very big event in Taiwan during every year. And we put the GPS in front of the kind of temple and also the camera. So you know exactly where the temple is now, because there are always thousands, tens of thousands of people following the temple one. So we know exactly where the temple is, and you can use the app to show to you where the temple is and where you can go to take a shower. If someone just walk with the temple for 9 days continuously, and you know where to send your things back and where you can receive any kind of cargo, any kind of goods, where you can take a shower, where you can get rest, where you can buy your food, where you can buy your souvenir, everything. Each year you track a lot of tourists each year. And there are so many downloads for this app already, and nearly 5 million views in 2023. So there are lots of system has been used in Taiwan. Lots of this kind of application: the trash truck, the garbage cleaning truck, and the service net. There are lots of this kind of system has been produced by different private industry in Taiwan, use a very good GNSS service and very good location service and very good platform. So there's so many different kind of version has been developed by the local private company in Taiwan. There are Thailand version, there are English one, the Vietnam one, the Japanese one. Well, just like this one. So it's showing like we can use this kind of platform in different kind of languages. Either it's English one or it's different languages in Japan or somewhere. So there's an international language, and like driving report, everything. So speeding report, continuous one, and also for each local map, we can use the OpenStreetMap, we can use the Google Earth map, or we can use someone producing their own map. So depend on where you are. Like this is the way in Japan. It's the same kind of algorithm, same kind of platform. It's exactly the same kind, but it's used in Japan now. So there are lots of like this one. This is in Thailand. So it's a Thai language, and also it's a Thailand map, and lots of like even the Vietnam one. So there are Mandarin Chinese one, simplified Chinese one, the Vietnam one, there are Thailand one, there are Japan one. So when I mean about the transportation management, logistic management, we say for some of the private company trying to make logistics more economically, more simple, more safer. But not only that, now everyone talk about the environmental, the social, the society, the governance, the ESG. So the ESG management will become one of the turning points in the logistic industry. I do think so. I do think so, because everyone talk about the net emission, and transportation is one of the very high consumption of the fuel and very, very high emission of the carbon dioxide into the air. So there are lots of this kind of application trying to make it more safer and also more efficient and reduce the idle time and reduce the waste of the energy. So we can say it's a green transportation or green logistics. So there are people talk about the green logistic, green transportation. Of course, if you change all the trucks into autonomous electricity trucks, then it might be better for the entire, but the way to make the electricity car is still very, very high energy consuming. So how we can use all this kind of statistics, how we can use all these kind of reports to make a very good and safer economic and also the environmental sustained for the transportation, for the logistics. I think who can make it, who will make the best market in the world in the near future. So I think this afternoon, I talked to you about the transportation, about the logistic, and how some of the Taiwan's private company experience can use the kind of GNSS service and with some other Wi-Fi or some other location-based service to create a good location, and with the maps and with all the kind of algorithm and analysis can make very good transportation, fleet management, and logistic management system. So I think that is one of the very, very good and very, very important application of the GIS, remote sensing, and GNSS. I hope you're enjoying the courses. This is Tien-Yin Chou from Fengyang University, the GIS Research Center. And I've been lecturer for this course continuously for, this is the third week. The first one was talk about the basic theory of the GIS. The second one was about the smart city. So this afternoon, this was the third one about the transportation and logistic. So after this one, the next 3 weeks, the lecture will be organized by my fellow colleagues. And they will talk about the data analysis, the UAV application, the drone, and some of the management issue using the GIS and the remote sensing. Hope you enjoy the course and still welcome for your staying on the online for the next 3 lectures. And also there will be a final one if you try to get the certificate, and you're welcome to register to Taiwan Space Union website for all the courses. This is already the 4th course offered by the Taiwan Space Union as an online free course to the world. I hope you enjoy the course. Thank you.
Wow, these 3 wonderful courses let everyone benefit a lot. We thank you very much, Professor Zhou.
Yeah, thank you.
Thank you. We end today's course. Please fill in the Google form and the 2-question quiz. If you have any questions, you can leave it in the Google form or email it to me. I will pass your questions to Professor Zhou. Thank you all for your participation. See you next Wednesday.